Okay, this is Mr. Gilmore for his Year 11 science class, just looking at a practice question for stoichiometry. So we're told here that hydrochloric acid can be used to dissolve aluminium according to the equation below. So from this you can observe that for every 2 moles of aluminium, you're going to get 6 moles of hydrochloric acid, or you're going to need, 6 mole of hydrochloric acid, and that'll give you 2 mole of aluminium chloride and 3 moles of hydrogen gas. But obviously here we're not starting with 2 moles of aluminium, we're starting with 5.4 grams of aluminium. So we need to calculate the number of moles in that 5.4 grams. So to do that, if we remember our triangles, where little m is mass in grams, big M is molar mass, that's in grams per mole, and N is the moles. From that we'll use the equation N equals mass divided by molar mass, because we know the mass is 5.4 grams and we can work out the molar mass. So to work out the molar mass, all we need to do is look at our periodic table. So the molar mass for Al is equal to, let's just have a look, 26.9815. Beautiful. So N is therefore equal to 5.4 divided by 26.9815, which equals 0.200 moles. I do apologise for this being a little bit messy. It's my first time using this iPad and this stylus, so it is a bit hard to draw with it as I'm not too used to it yet. So hence, calculate the volume of 2 mole per litre concentration hydrochloric acid solution needed to completely dissolve 5.4 grams of aluminium. So we need to work out the moles of hydrochloric acid required to then work out the volume. So if we think back to our other triangle, you've got N equals CV. C equals N over V. And V equals N over C. So we're being asked to calculate the volume. We know the concentration, which is given to us here, but we don't know the moles. However, we can work that out. So if we remember back to our equation from earlier, the moles of the unknown is equal to the moles of the known multiplied by the coefficient of the unknown divided by the coefficient of the known. So therefore the mole of our unknown, which is going to be our hydrochloric acid, is equal to the mole of the known, which is our aluminium. So mole of aluminium was 0.2, as that was worked out in that first step above, times by the coefficient of the unknown. So our unknown is our hydrochloric acid, so the coefficient is 6, divided by the coefficient of the known. Our knowns are aluminium, so that's divided by 6 divided by 2. That equals 0.200 times 3, and that's equal to that's equal to 0.600 moles. So that's our mole of hydrochloric acid. We're not quite finished yet because we're being asked to calculate the volume. So our volume equals N over C. Therefore, the volume is going to be equal to 0.6 divided by concentration, which was 2.0. And that gives us a volume of 0.3 litres. I'm not being too stressed on significant figures with this today. Alrighty. Lastly, calculate the mass of hydrogen gas evolved in the reaction. So, once again, if we know the mole of anything, we can work out anything else in the reaction. So to start with, we want to know what the moles of H2 gas is produced for every 0.2 moles of aluminium dissolved, whatever it is, dissolved. So from that, once again, using that equation from earlier, the n of the unknown is equal to the n of the known times by the coefficient of the unknown divided by the coefficient of the known. Therefore, the moles of hydrogen gas is equal to the mole of, we'll go with aluminium again, which was 0.20 times by the coefficient of the unknown, which up here is 3, because hydrogen gas is our unknown, divided by the coefficient of the known, which again is 2. 0.2 times by 3 divided by 2 is equal to 0.3 moles. From that, going back to our triangle up here, we can see that mass equals moles times molar mass. So we know the moles and we can work out this molar mass. So flicking back to our periodic table, the formula is H2. Therefore we have 2 H atoms. Therefore our molar mass equals 2 times, just show you, 1.008, you can see in the top left corner there. Where'd this go? Okay, bit weird it's disappeared. But it was the mole of hydrogen was equal to 0.3, and then the mass is going to be equal to mole times molar mass. Molar mass is equal to 2 times 1.008, which is equal to 2.016 grams per mole. Therefore, our mass is equal to little m times big M. We know both of those now. So our mass is equal to 0.3 times by 2.016, and that is equal to 0.6048 grams. Lovely. Thank you for watching, guys. I apologize again that it is a little bit messy. Just once again, it's my first time using this iPad and making this first video, so you know it's a bit weird to get used to. All right, any questions, you can email me on my email. Thank you.